Hello world! This is a small hint because we are going to do some easy programming together. Maybe some of you saw my last video where I showed you how I built my awesome gaming setup in my closet. If you haven't seen that yet, go watch it. Link in the description down below. In this build, I showed you a very unique feature. LED memory cover that show you how much memory you're currently using. Today I want to show you how I did that and most of all how you can do it yourself at home. This project will involve some programming, but don't be afraid. I will provide you with all the code and explanation how to do it. This tutorial is very beginner friendly. So let's start. All you need is right here on the table. I bought these very inexpensive LED memory covers. Link to them in the description down below. They come with thermal pads and also these spacers if you only have memory chips on one side of your memory. But modern memory comes with heatsinks already installed. Please do not try to get those off. I learned it the hard way. I made this mistake so you don't have to. Turns out they are factory glued and you will rip your memory chips off the board when you try to remove them. Okay, let's get rid of those. The next thing you need is a Raspberry Pi Pico W. They are very inexpensive. They used to cost around $9, but because of the chip shortage, they got a little bit more expensive. But you should be able to pick one up for a few dollars. It is important that you use the Pico W, you see it on this little chip, because we will use Wi-Fi in this process. You will also need a micro USB cable, some wire cutters, a highly professional wire stripping tool, some heat shrink, a soldering station or soldering iron, some solder, and to make your life a little bit easier, one of those that is called a lazy boy.
Second, lazy boy and the...
Just to hold your wires while you solder. So, enough talk, let's build. Within these memory covers, there are just addressable LED strips. Normally they are attached to your motherboard using these 3-pin connectors. Because my motherboard does not have an LED out and because I want to have my Raspberry Pi Pico W to control them, I cut them off. For better access, we will get the LED straps out of the case. You do this by opening these 2 screws and pulling them out of their case. I've gone ahead and removed all 4 of them and split the wires. They are just like glued together, you can just split them apart. And I also took the isolation of the ends of all the wires. Now that we got all of our strips out of the casing, we are ready to solder. On top here, you see 4 connectors. On top of the strips, the connectors are neatly labeled. You have your 5 volts, your D in, which means data in, your ground, and your D out, what means data out. We are only using those 3, 5 volt, ground and data in. The data out we can ignore. Because we don't want our Pico to hang in front of our motherboard, we have to elongate these cables a little bit. So I just solder some cables on there. Be sure to color code them so you can differentiate them later. So let's get to soldering. I'm done with the soldering. As you can see, I chose blue for 5 volts, purple for data in, and white for ground. It's really important that you are sure that you did it the right way, because otherwise you will produce a short later on. You can easily check that, because if you connect it later with the program on it, your computer will tell you that your USB port is demanding more power than it can deliver. But for me it was easy, because in all of my builds, I am very tidy and organized. Really? You couldn't have let me that one. So now let's get these wires into one single wire so we can connect it to our Raspberry Pi Pico W. I finished to get all my cables into one single cable. Let me tell you, a good wire stripper would have gone a long way. So please subscribe to my channel so I can afford a wire stripper. So let's connect it to our Pico W. The 5 volt wire goes to V-bus on the top right corner. Your DI or data in goes to 28 and your ground goes to the 3rd ground on the left side. Your wiring should look like this. So let's put them back into their case. As fast as that, the mechanical part is over. So let's move on to the programming. Just go outside, find a guy that looks like me and ask him if he's a nerd. That should work, right? Let me test that hypothesis.
A few moments later.
Yep, don't do that. Hypothesis. So, I installed all my new lit up heatsinks on top of my existing heatsinks, and I used the thermal pads to connect them to the old heatsinks because we are covering some area that is normally used for cooling, so it's best to use the aluminum of those to get that heat and disperse it further. I installed these now in my PC. Let's fire up my PC and let's go to programming. By the way, if you want to know how I built this setup here, check out my other video on the hidden PC gaming setup. Because I already pre-tested everything on my PCB, I will use a brand new one. So I make sure I don't skip a step or anything and this tutorial won't function with you anymore. So I will install all the code here, get everything up and running, and then of course switch over to my soldered board. But the tutorial itself will not be affected with it. As you can see, I have quite a lot of those Raspberry Picos because I'm in love with them. They are super affordable, they are easy to program, they are very powerful and they don't require that much power. So first thing you want to do is to plug in your Raspberry Pico and it will actually show up as a USB thumb drive device. That's already good. First thing you want to do is go to the website and install Tony.
Hey Tony, I know you.
We will use Tony for programming the PCB and also for test running our LED. So next we need to install the firmware for our Raspberry Pico W. This is done pretty easily. As I showed you, your Pico just connects as a mass storage device. Just download the file that starts with RP20 from my description down below and simply drag and drop it onto your mass storage device, on your Pico W. It will automatically reset the Pico W and reconnect it, but now it's programmable. Next, start your Tony editor. We have to set our interpreter to MicroPython Raspberry Pi Pico. Save that. So as you can see here, I disconnected my Pico and it stopped showing. So if I reconnect it now, and when I restart Tony, it has the interpreter open again. So I know we are connected to the Raspberry Pi. If you don't see that field down here, go to View and toggle on Shell. Shell is basically our window where the outputs are and also where it shows our running program. Also, go to Tools, to Options, Interpreter, set this one to MicroPython Raspberry Pi Pico and also to detect automatically. Okay, with that, setup of Tony is so far done. We need to install some packages to actually be able to use all the programming that we intend to use here. Packages or libraries enables you to use predefined code that is already saved on your Pico without having to write all the little details. So I give you, of course, all the packages and libraries you need down in the description below.
Andy built a library.
As of the making of this video, I just discovered that the newest release of Tony has a critical error when you try to install packages. I originally did that on the version 4.0.2, and so I'm now reinstalling Tony 4.0.2. Just so you know, go to GitHub and download this version if you want to follow this tutorial. I don't know if they will update the software. I saw some people on the internet complaining about this error, that they have the same and that it tells you to hard reset your Pico W if you want to do anything. So yeah. So now we are back to Tony 4.0.2. First thing we do again is, because it's a new installation, we go to the interpreter, still saved, great. So we go to manage packages. We type in network. We click on network and we install this package. Now it works. So network is now installed. Next, we have to go and find socket. And we install this socket. That's the two things we have to install. Next, you go to this link. I will provide it in the description down below, and download or copy the code NeoPixel from Blaze R. Copy all the code into Tony, just in here, press File, Save, say to Raspberry Pi Pico and name it neopixel.py. Okay, it will now save it onto the Raspberry Pi Pico. So the last step to do is go in the description down below, download my script main.py and open it in Tony real quick. We go to File, Open. From this computer, we just go and open main.py. So this is all the code you will need. It's pretty simple. The thing you need to change for your specific setup. Line 7 is the name of your Wi-Fi and line 8 is the password to your Wi-Fi. So our PC will broadcast its memory usage into Wi-Fi and Raspberry Pi Pico W will basically grab that information and display it as a color. So after you open it in Tony, go to Save As and say Raspberry Pi Pico and name it again main.py. Press OK, done. When you press Run on this code, down here it should appear connecting to Wi-Fi, Wi-Fi connected successfully, and display your IP address. The IP address in this case, or in our case now, is 192.168.1.65. Copy that number, because we are going to test now if we can reach our Raspberry Pi Pico in our network. Simply press Windows key and R and type CMD. This is your programming window or your command window from Windows. So here we can simply test if we can reach our Raspberry Pi Pico W in the network by just simply typing ping and our IP address. It will send a ping through the network, which is basically a little knock-knock for the Pico to answer to. If the computer is successful in finding the Pico W in the network, it will give you the response times that needed. If not, it will give an error. So we press enter, it pings, and you see we get back a response time of around 100 to 200 milliseconds. That means our Pico W is set up, it's reachable, and it's now linked in the network for our RAM broadcast. So the next thing you need is my script that is called Memory Final. Open this with Tony. So now in line 5, you have to enter the IP address Pico just gave you. So in order for your computer to broadcast its memory usage into the network, we first have to install Python on your computer. Go to python.org and download the latest Python version. Install it using admin privilege. Python has to have access to your system resources for what we want to do, and if you don't install it as an admin, it might block it from doing that. So now that we installed Python, we now have to add Python to our system variables, so it is accessible from everywhere in the computer. The easiest way I found especially is to simply run the installer again and choose modify here. And then click next and click the option add Python to system variables. Click install and it's done. Now your Python is accessible from everywhere in Windows. So now we have to install some packages or some libraries again, but this time for the PC, not for your board. Bring up your console again. Next thing you want to type is pip install psu till. This installs a library that is able to monitor your hardware. Next thing, you want to install Pi installer by typing pip install Pi installer. This program makes it possible to produce an .exe file out of your Pi script. Now we want to navigate to wherever we will save the script or the produced exe file. When you are navigated to the folder where memory.py is saved, simply type Pi installer one-file memory.py. This will create an .exe file out of your script. If you want to skip all of this process, you can simply download the ready-made .exe file from the description down below. After the program successfully processed your Pi file into an .exe, you find the exe file in the folder dist. The next thing we need is a program that I personally think has the best name ever, the non-sucking service manager, because the service manager of Windows sucks for real. So go ahead, download that. I unpacked it into the same folder than my script. Using the command console, you again have to navigate into NSSM, into the folder Win64. There you simply type nssm.x install rum service. Rum is the name how your service will be named. Using your Windows menu, simply search for services or in German Dienste and open it. There you can see your brand new system service. If you try to start the service, you will see that you get an error message. That is because we haven't configured our service yet. Go back to your command prompt window and type nssm edit ram. A new window will appear. It's the nssm service editor. Here in path, you simply choose the part where your .exe file is located. As we learned, it was in the ordner dist. And as a directory for the startup directory, also choose the same folder. Press edit service. It will show you a message. Service RAM edited successfully. So from now on, every time you restart your computer, the service RAM will start. And you see I start and stop it here to test it out a little bit and see my life. Also, please check that the start type is set to automatically. That will make sure that it starts automatically every time you start your computer. And as easy as that, it works. Was it overly complicated? Yes. Totally over-engineered? Of course. Was it completely unnecessary? What the hell, man? Stop to criticize me in my own script. Come here, you little... Yes, Daddy. What?